So sometimes you want to be able to pass in a series of values to a method, and you don't want to put different variables in to catch each one. If you know what overloading is, and I think we've mentioned it, then you could write something that looks like this. Void print me, and it takes string s1 and string s2, and whatever. It's going to console.out.write line, string s1 plus s2. Great. Then if you wanted to make another one that would accept 3 strings, then you could do void print me, and it takes string s1, string s2, I forgot. Make that s2. String s3. Do it again. And you could print those 3 guys out. And you could make another one that was overloaded with 4, and one that was overloaded with 5. But what if you just wanted to make it so that it didn't matter how many? Print s1, press s2, press s3. So you could call that like this. Print me, and you could give it, 2 strings. You could call print me, hello, my friend. That would work. And then you can't do this. I love C#, because we don't have an overloaded version that accepts 4 strings. And as soon as you add that one, then you're going to need one that accepts 5 or 6 or 10 or 20. And so the way to fix that is to use parameter arrays. A parameter array lets you write just one function. You don't have to keep overloading it. But all of the parameters you pass in are treated as though they are members of an array. So once you process it in the body of your function, in the body of your method, you're going to be iterating through an array. So you could use an array as your method, as your parameter for your method. Like void print me, and you're going to take an array of strings like that. And then you could have a for loop for each, string in SA, do something with it. It's the same idea. But let's go take a look at how it is invoked. So a local array declared within the method header by using the keyword params. So we're going to have to use a keyword. Why do we have to do that? Because otherwise, if we were going to do this, we'd have to create our array first before we called it, right? We'd have to create an array, of names or whatever. And then when you called it, print me, names, like that. This is an essential step if we were going to implement this solution just purely as an array of strings. We instead want to make it where it'll work like this, where we don't have to convert it into an array first, and it gets magically converted itself. And that is done with the params keyword. Like this. Come back. Display strings, params, string, people. Then when we want to call display strings, we can do display strings. We can pass in one name, and then the array called people has one element. We can call display strings with 3 names, so the people array has 3 elements. And this is showing that if you want to turn around and pass in an honest-to-goodness array that you've pre-prepared yourself, just like I was kind of doing on my notepad, then you can do that as well. So you can either pass in parameters separated by commas, or you can create an array of this type and pass it in, and we'll treat it the same. All right, so I just talked about overloading methods before we got to it. Did we cover overloading methods on Monday?
Yes.
Yeah.
Because we made one that a change me method, and we had it taken in a double. So.
Okay, yeah. So we've overloaded methods. Good, because I was just talking about them. So let's go ahead and write something that takes a parameter, a parameter list, a parameter array. So static void add. We're going to take something that takes a bunch of numbers and we'll add them together. Params int numbers. And now we just need a for loop, which will iterate through those. So for each int in numbers, why are you giving me grief there? No. We'll add that to a total. So we have to declare our accumulator beforehand. I shouldn't declare it as void because I actually want it to return what we're doing here. So static int add params int numbers, just like that. Then let's declare our accumulator total is equal to 0. And then for every element in the numbers for each int in numbers, add that to our total. Total plus equals n. Then we're going to return total. Like that. So that's our method. And since it accepts a parameter array, if we'd left off the word params, we'd have to create an array and pass it into our method. But we don't have to because we have the params array. So we can do things like this. Console.writeLine add 10, 20, 30, 40. Should print out 100. Or console.writeLine parentheses add 10. It should just print out 10. We're only adding one thing. What if we don't pass anything in? Console.writeLine console.writeLine parentheses add no parameters. That's fine. You just have an array of 0 length. For each doesn't care if the array is 0. It just doesn't go into it. So we will return a 0. I'm going to space this out just a little bit, make it a little bit clearer to read. All right, so what we expect to see is that 10 plus 20 plus 30 plus 40 is 100. 10 all by its lonesome is 10. Nothing is 0. So when I run it, those are the values that I want to see. I'm going to add a console.read key at the end.
So the parameter, if you use a params keyword, it's optional. You don't have to have anything in there.
Right. You're still creating an array, but it's an array of 0 length. So you just better not access any element in it. And the for each loop handles that just fine. Or you could check the length of the array, make sure that before you try to access it with an index. All right, and it printed 110 and 0. Or if you feel like it, you could create an array of ints and pass it in old school. Int numbers is equal to 1, 2, 3, 4, 5, and then pass that in. Console.writeLine add those numbers together. And that should print out 15. Right? Yes. Yeah. If we had left the params keyword off, the only one of these methods that would work would be this one. The rest of these fail. The only thing we could pass in would be an honest-to-goodness array of numbers. So I'm going to stick the params keyword back in there to allow that to work. So overloading is the ability to have several methods. We could rewrite this method so that it accepted doubles. And I know we've already talked about it, but I feel like doing the doubles as well. Static double add, and it takes an array of doubles. declare our accumulator. We better make this a double. Double total equals 0 for each double D in the numbers array. Total plus equals n. Return total. Oh, I called it D right there for error. So total plus equals D. Just had to fix that. For each double D in numbers, total plus equals D, return total. So now down here, we have a problem now. It doesn't know which one of these to call. That's an interesting problem. The only way I see how to fix that is to overload a third one that doesn't accept any parameters at all. Why are we getting that error? Because if you're not passing in any array, it can't figure out whether you're passing in a double or an int. So we've kind of broken that neat functionality to where we could pass nothing in. So I guess for that, what I might want to do is do this. Overload it one more time, double add that doesn't accept anything. And what does it do? It declares an empty array. Int empty is equal to that, and then we just return the added version of that empty array. We take advantage of one of those that we've already done. So now we've overloaded the add method 3 times. We wrote one that takes no parameters. We wrote one that takes doubles. We wrote one that takes integers. And if you mix the types, they will be treated as doubles. Let's prove that though. Console.writeLine add 1.0 to 2.0. That should work, right? Yeah, no error there, but let's add an int to a double. Console.writeLine, just make sure that it can handle this. Add 1.0 to 2 without a point. And that'll work. It has figured out that since one of these is a double, everything's going to have to be converted to double and then invoke that overloaded method. All right, does that make sense?
Is that implicit casting? Is that what happens?
Yeah, right. It's doing some implicit casting on these parameters to get that one to be a double because it knows it can't implicitly cast that down to an int without losing data. All right, so we've demonstrated overloading again. Happy to have done that. We've also demonstrated params. You can only have one params keyword. Don't bother typing this because it's not going to work. Static double add, and I wanted to make it take both an array of ints and an array of doubles. That's not going to work. You can only have one parameter list. Why is that? Because how would it know where to stop? How would it know which parameters were supposed to go into that one and which parameters would go into that one? And you might argue, well, just put all the ints in there, and then if you see a double, start putting it in. No, that's way too much work for it. It's just not allowed. I'm going to delete that. Overload resolution, how C# determines which method to execute. So it's got inside of itself, the compiler has a set of methods that can accept a call with a specific list of arguments. And then betterness rules, those are the rules that determine which method version to call, similar to implicit data type conversion. And so If the data type is byte, it can be converted into a short, a ushort, an int, an unsigned int, and so on. An int can go into a long or a float or a double or a decimal. A long can go into a float, a double, a decimal. The unsigned ones, you know, can go into the unsigned ones or the assigned ones. Discovering built-in overloaded methods. When you use the IDE to create programs, Visual Studio's IntelliSense, the tooltips that pop up, features provide information about the methods you are using. So, the convert class, for example, has a whole bunch of different overloaded methods. So double, well, int 32 test is equal to convert dot to int 32 parentheses, and we'll see that there are 19 different versions of it. You probably can't see it here on the tiny screen, but you can on your own, and you can just click your down button to see how many different versions there are. One of them will take an int, one of them will take a long, one of them takes an object, which is interesting. It has to be an object that implements the system.convertible interface, which we haven't talked about interfaces. A short byte, a short, a string, an unsigned int, and so on. So the makers of C#, Microsoft has provided, 19 different versions of 2int32 so that it doesn't matter what you're trying to pass in. It can do the conversion. And that's cool. That's better than having 19 different names that you have to memorize. Also, when we're writing our own, double x is equal to add parentheses. We have 3 different versions of our add method now. And so it says 1 of 3. One version doesn't take any arguments. The next one takes, our doubles. And the third one takes our integers. You got a question?
Yeah. So when it comes to like the decimal, when you convert an int to a decimal, how come when you print it, it still displays just as an int?
Well, so if you convert it into a decimal, why does it print as an int? What if you use the decimal formatter when you did your print? I don't know if that works or not. But otherwise, the question is, the answer is that it doesn't matter. If you try to print out a float, it's not going to add decimal points unless you told it to. And same for decimal. It's not going to add decimal points unless you told it to in a formatting string.
Oh, okay.
Yeah. So avoiding ambiguous methods. An ambiguous method, a situation in which the compiler cannot return or determine which method to use. That occurs when you overload methods. Methods with identical names that have identical parameter lists but different return types are not allowed. So we have this cute version here, static double add. What if we thought, well, I need to make one of those for ints too, static int add. And if you pass nothing to it, you're going to return a 0. That is an error. It doesn't show the error being right here, but the error is when yeah, it is right there. Let's try to build it. We have an error in our error list. Already defines a member called add with the same parameter types. And the reason why is, how would the compiler know which one of these to invoke? The compiler knows which one to evoke by the name of it, followed by the parameter list. It doesn't care about what's in front of it. The compiler doesn't look at, whether this is a double or an int or whatever, because everything gets evaluated on the right-hand side of the expression. And so just looking at this, it doesn't know which one to call. It can't determine. So that's not allowed. You can't write something that has identical parameter type lists but return something different. And it doesn't matter if you had two things with the same name with different parameter names if they were the same type. I mean, maybe that's obvious, but you know, if you had a function called testMe and you passed in int I, and then you had another one, void testMe, that took in, you know, an int and you called it x, really there's no difference between those two, right? There's no way the compiler could figure out whether you wanted, you know, your argument to be stored in the I or in the x. So again, that's a syntax error. Won't compile. When you're overloading, your parameter lists have to be decidedly different. Either they have to have different types or different numbers of arguments, or both. Now I'm kind of wondering how it would figure out, what if we created a version of add that just took two ints? Would it know to call that one rather than the one with the arguments? Let's see. Static int add int a1 int a2. Now there's been absolutely no reason to do this. This is just a test. Return a1 plus a2. Cannot implicitly convert type double to int. I thought we'd fix that. Oh, yeah. Sorry, I introduced this error when I added this line, right? So. Okay, so that did work. We do have a version of add which accepts just two. Let's find out which one gets invoked. Console.writeLine. Add int a1, int a2 called. And that will probably be the one that is invoked by this statement right here where we added two ints. We never did add two ints. Here we go. Let's do it right here. So I'm changing this console.writeLine to add 10, 10 because I want to see if it's going to print that message out. Yep. So it's selectively decided that something with the correct number of arguments is better than passing it in as an array. Would you do that? No, you wouldn't do that. There's absolutely no reason to provide, in my mind, a specialized version of this if this one's already doing the correct case. I'm going to delete that. It's unnecessary. Optional parameters. We did optional parameters. Leaving out unnamed arguments. When you're calling a method with optional parameters and you're using unnamed arguments, you can leave them out. Of course you can. That's why you have optional parameters. Named arguments, we talked about those. Those are really cool. Named arguments are when you can invoke something like this, where you say argument D is a 2.1, argument C is an 88, and argument A is a 12. Whoopsie. So the advantages to using the named arguments gives you flexibility with the method calls. The arguments can be in any order, as long as they follow all the unnamed arguments. So display employee data, employee imp data should hide salary true is better than just saying employee data imp number true. Makes it real clear what the purpose of that function, what the purpose of that argument is. All right, looks like we're at the end of this. Method parameters can be mandatory or optional. We know that now. Types of mandatory parameters: value parameters, reference parameters, output parameters, and parameter arrays. I think that reference parameters and output parameters are so important, I don't mind typing in an example of them one more time. So we're going to write a function called divide. It's going to accept two ints. It's also going to accept a third int, which is going to be the answer that gets passed back, and it's going to return a bool indicating whether it's worked or not. And why wouldn't it work if they tried to divide by 0? So static bool divide. The numerator, the denominator, int denom, and then the output, int result. So we need to check to see if the denominator is 0, and if it is, we're going to return a false. So if denom is equal to 0, we have a problem, we're going to return a false. I guess we should store something in result before we do. That's probably what it's complaining about. The out parameter must be specified. Okay, sure. Why don't we just set result equal to 0? And then we'll assume that the programmer is smart enough to know not to trust the result if they get a false when they call divide. Now, if that wasn't true, then we need to calculate the result. The result is equal to the numerator divided by the denominator, and we're going to return true. We can test it out. I'm going to cut that and paste it right above main. Cut, find main, paste it there, just so it's, easy to find. So down in main, bool, okay, int result, or let's do int x, y, z. X is equal to 3, y is equal to 4, and let's call our divide function. OK is equal to divide x, y, z. And if OK is true, then it means we can use that value. Now I made a mistake because you have to provide the keyword that matches that keyword. If this keyword was ref, I'd have to put ref here, but the keyword here is out, so I need to put out there. There are other ways of handling this. There's exception handling. If the function cannot, if the method cannot do what you want it to do, it can throw an exception. Terms that we haven't quite covered yet in this class, I do not believe. Okay, so then if OK, you could do something. Console dot write line divide returned, placeholder 0, end quote, comma, result. Nope, it's not result, it's C. No, it's not, it's Z, excuse me, because I called them X, Y, and Z. Should I have given a better variable name than Z? Yeah, probably.
Try divide.
But, pardon me?
Say, would it, so in this, well, so this is like try parse and...
Exactly. This is a try parse kind of thing, where try parse returns a true or false if it succeeds or not. Divide is returning true or false. So if not okay, we're going to write a different message. Console.writeLine divide call failed. Good enough. The first time we run it, since 3 and 4 are divisible values, we're not going to see that message. It says divide return 0. Sure enough, because we did integer division, let's change it so that it's 8 divided by 4 so we don't see 0. 3 divided by 4 rounded down is in fact 0. So there's our code again. Run it. Yeah. Divide return 2, which is true because 8 divided by 4 is 2. Now let's change our denominator to 0. 8 divided by 0 is going to be an error. And the divide call failed. So the reason you use these output parameters is when your function can't simply just return one value and be called done. And what if you need your function to return 2, 3, 4, 5, 6 values? Well, there are other ways of handling this. You could create an array of return values or whatever, but a nice clean syntax is to use these out parameters.
Can you have multiple out parameters?
Yes, you could have multiple out parameters. Like void, static, void, test it, out int A, out int B. And inside here we set A equal to 100, B equal to 200. And then when we invoke it, int X, comma Y. And then when we call test it and we passed in out X and out Y, when it was done, X would equal 100 and Y would equal 200. Yeah, so that does work. If you want to preserve the values as they go in, but you do want them to be changed, you use a ref keyword instead. So, I don't know why you would write this function, but we're going to write a function that returns the cube value of the parameter, but instead of returning it, it's going to set the reference variable back. So static void cube it. Reference variable int A. So ref int A. What does it do? A is equal to A times A times A, right? The cube value of A. So down here in main, you could do that. Int number is equal to 3. And then you could call cube it reference number. And by the time it was done, since 3 times 3 times 3 is 27, if we printed out number here, we would see 27. Console.output. Console.write, excuse me. Qubit set number to placeholder 0 end quote comma number. Or not. Have a build error. A local variable x is already defined. True enough. I should have used something else rather than x. I'm just going to comment those two calls out. They would have worked if I weren't redeclaring variables. So there we go.
Was it that you said that if your out variables, can they already be initialized?
They can be initialized. Yeah. Can the out variables be initialized? Let's change this to something that would actually work, just so that we can prove it. I'm going to call them I1, I2, and then when I call test it, I'm going to pass in out I1, out I2. And we can just write those out just to prove that it works. Console.writeLine, test it, placeholder 0, placeholder 1, comma I1, comma I2. I seem to have a syntax error going on up there. Nope, it finally underlined it. Okay. It doesn't matter whether these are initialized or not. The values get blown away.
Okay.
What out means is that in this code here, we can't do anything with it. If we tried to do something like this, if A is equal to 0, A is equal to 100, whatever, it's not going to work because this is guaranteeing that we're ignoring whatever value was passed in if there was one.
Oh, so what we went over was references. You have to have a reference variable initialized to use it.
Right, exactly. A reference variable does have to be initialized before you use it. An out variable can be initialized, but it's completely ignored. Yep. When you overload a C# method, you write multiple methods with a shared name. Okay. Any more to our summary? When you overload a method, you run the risk of creating an ambiguous situation. Well, yeah, you run the risk of it, but at least it doesn't compile, right? So you have to fix the problem. It's nice when the compiler catches problems. Optional parameters is a method by which you supply a default value. And they don't even have a summary of named parameters. Reread the PowerPoint in the book over named parameters. So we already have a homework assignment over methods. Doesn't cover everything we've covered. I'm pretty sure it doesn't cover named parameters.
It's in part of it says for bonus make
An overloaded one per parameter. Or parameter. Yeah.
Let's go look. Write an overloaded method which will calculate the surface depending upon how many. Turn in a version that uses the params keyword. So we are using the params keyword. I kind of wish that I hadn't even made that extra credits, but some people have already turned it in. And it does not use named parameters. Kind of like I need to make another assignment over this chapter. Alright guys, I am going to remove the idea that this is extra credit. Also, write a calc area P method that uses a params keyword to accept 1 or 2 or 3 int variables. That's good enough. Don't need to modify the assignment any further. And if you've already turned in the assignment and you didn't do that, that's okay. All right, I think that's about enough. So, see you next time.